Aziz Khan. So as we were talking about the antenna requirement, so let me take you to the radio side now, because we have a link. So we'll put some antennas and we'll put some radios, uh, IDU and ODUs. So what are the important factors for radio? Is again frequency and hop length, some of the radio features, and XPIC and MTBF of the radio. These are only some of the things, as I told you, that I will just start as an introduction, and then we will go and we will build over it. So just as the antenna one, I will show you similarly. This is a radio specification, not same but similar to the antenna specifications. Like, it also has the frequency bands and the specification based on the bands. So if you see the frequency band for the 6 gigahertz, it's exactly same like it was the frequency band for the antenna in 6 gigahertz. Let me show you, so that you see this 5.925 to 7.125, and it was called 60. So this is 5.925 to 7.125, and this is called 6 gigahertz. So this is where ITU come into play. I mean, ITU make recommendation that if you are building something for 6 gigahertz, it must follow this recommendation. I mean, otherwise, for example, if the radio manufacturer takes 6 gigahertz at something else, and the antenna manufacturer takes 6 gigahertz at something else, then maybe I buy a 6 gigahertz radio, but with my 6 gigahertz antenna, it is not working because this guy says that my 6 gigahertz is something else. So that's why these are important as well. And so we have this frequency band, and then below is the frequency range as per the band. Then these are modulation schemes which are supported. This is some STH old type of equipment, but the new equipment, they have very much higher software modulation. This modulation is software selectable. Here they have written specifically. Now they don't write it. They know that everything is, all the radios are software based now. But the things to see here is that the channel spacing it can support, but different channels have different capacity. Like for example, in QPSK, if you go to the highest, and if you see on 28 only, 28 can support 20 evens. But on 16 QAM, the same 28 can take 40 evens. So it can take double the capacity. And when you go to 32 QAM, you go further. I mean, you go to 48 evens. So from here, it is almost 2.5 times capacity. So it means that if we increase, so nowadays we have 1024 or 2048 and 4096 QAM. A 4096 QAM may run like 200 evens, maybe. I mean, I'm not very sure in the same capacity. So, but this is not the only thing. I mean, if we just increase the modulation and the capacity is increased, then this was fine. I mean, we should be good with it. But the problem is that as you increase the QAM, you have some things automatically decreased. We will go in detail. We will learn that why it happens. We will go to the technical side of it. But the channel gain, the system gain, it deteriorates. The channel gain goes down as you increase the modulation. So increase modulation in a normal condition works best, but when the weather is bad or there is anything on the link, then you have to switch to a lower modulation so that you can keep running, because in lower modulation your threshold, your transmit power, your total system gains, they all increase automatically, like you can see from here. On QPSK, it has, for example, here it has 113 system gain, but on 32 km the system gains go 13 dB below automatically. So this was the reason. I mean, this was I was specifying. I mean, when you increase the modulation, you lose the total system gain. So you have to keep in mind when you are planning a link, you should keep in mind that there may be bad weather as well. So we should take care of the link, that how it works in different kind of weather. Again, I will go in detail of everything. I will show it. Path loss can show you these kind of things as well. It will tell you that what will happen to your system, how much time it will run in the best part, how much time it will run in the worst part. So it will show you everything, and we will also see that. But when you are planning for the first time, then you should have these things, these ideas should be in your mind, that this kind of things happen, that kind of thing happens. So for example, to mitigate this, there's a MTPC or ATPC. MTPC is manual transmit power control, and this is automatic transmit control. They are similar thing, but this, when you are in ATPC, it works automatically, and when you MTPC, it works manually. You have to change it to something. But the good thing is that one mitigation is, for example, if you have a link and it was working on the best QAM, but the weather is becoming bad. First thing what it will do, it will try to increase the transmit power with the ATPC, with the help of ATPC, it will increase transmit power, how much it may increase, I mean. But maybe it went to the best part, I mean, it take you the full transmit power, still the weather is too much bad. Then it will start the modulation to bring it down. Because, for example, if you are in a city and you increase the transmit power because of rain or anything, and it is not automatic, someone manually did it and he forgot to bring it down, then when the rain should be gone, I mean, the rain subside, your link is still working on a very high power, then it may start hitting, it may start creating interference to other links. So that's why ATPC, what it does is that it increases the link, then it decreases as well. When the weather is fine, then it takes it down so that your link start working in the best possible way. In the below here, these are physical thing, I mean system thing, like how much interference, how much type of interference card it have, little cross connectors, what type of traffic is even and LAN and whatever. You have service channels for NMS purposes. Then you have some compliance of IDU and ODU. This is ETSI compliance. I mean that how much, what kind of weather it can sustain, how much temperature difference changes, whatever. I mean. Then usually what kind of antenna are, because ODU should fit on some specific antenna, ambient temperature on which it can work. Then you can connect an LCT or NMS. Then there are dimensions and how much big it is, how much weight it has, and power consumption. When you are putting these, looks very small like 60 watt, 102 watt. But when like working in Pakistan, I know when electricity is gone and your system comes on the backup power, then even this 60 watt or 100 watt, it becomes too much, I mean. So you have to take care of this as well. And input voltage, EMC, something that I have mentioned in my here. So we talk about frequency, hop length, features, ATPC, adaptive modulation. Then we have XPIC and MTBF as well, which I just wanted to cover right now. So XPIC is the cross polarization interference cancellation. So just like we had XPD or cross polarization on the antenna side, the 30 dB difference in horizontal and vertical. Similarly, on the IDU, we have XPIC ports that we can physically connect, and they cancel some interference of the cross polarization, and they give you additional discrimination. Like for example, if you have 30 dB from the antenna, you may have 30 dB from the equipment as well. So your horizontal and vertical, they are now separated a lot, I mean, and they don't cause any interference between each other. So XPIC value is also very important, that how much XPIC your antenna support XPD and how much XPIC your radio supports. And then we come to MTBF, kind of last part of my slide. So MTBF is mean time between failures. It gives you an idea that how much usually a radio will work without breaking, without failure. Like for example, you put any equipment and like for example, if you have a motor which is running, you see that the motor becomes hot, and we say that don't run the motors for too long because they may burn. Similarly, like if we have any equipment at our home, usually they have a time. I mean, we run it for example 1 hour, then we let it cool down. But the problem with radio is that it has to be run continuously, day and night, every day. So it don't have any chance of stopping for a while and taking some breath and then run again. No, it has to be run. So we have a MTBF value for it. That, for example, it can run for 60,000 hours continuously without a failure, or 100,000 hours, or whatever. The good radios, they can run for many hours continuously, and the not good radio, they run a bit lesser hours. So this value is also very important. Whenever you are selecting a link, you should take care of MTBF as well. This was not mentioned here, so I mentioned it separately. So we can see that we have generally I have covered some things. So basically, as I talked in the antenna video as well, that when we are making a link, let me take you to this as well. So just like we put an antenna here because of some specification, some values. Similarly, we put a radio here also because of some values. For example, if we put a radio of 10 gigahertz, so we must put a IDU also for 10 gigahertz because they must be compatible. And then we will see that if the values which they are providing, does it correspond to a stable and a nice link or not. So we will see, we will put different kind of links on path loss, and then we will compare and we will try to talk on these kind of things, that in which area what kind of link should be put and which area what kind of link should not be put, why we should put which frequency on which length and which frequency on the other lengths. We will talk all of these things, and I hope that this introductory video should be beneficial for you. But again, as always, I want you to please ask some questions if you have, so that in my next coming videos I have some idea in my head that I will make some videos based on my idea. But if you can give me some of your feedback, then that will be great. So let's meet in my next video. So goodbye.